Check. 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 Testing 1 2. Testing 1 2. Testing 1 2 3 4 5. Testing 1 2 3 4 5. Check. Testing 1 2 3. Check. Testing 1 2 3 4 5. Testing 1 2, testing 1 2, testing 1 2 3 4 5. Check, check, testing 1 2. Check, 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 testing 1 2 3 4 5. Check, check, testing 1 2 3 4 5. Check, check. Check, check, testing 1 2 3 4 5. We are live. Hello everyone, and welcome to Alan's Astro Livestream, where we look for the strange light in strange places. I'm Alan, I'm your host. I am an amateur astrophotographer, a professional photographer and videographer. Digital media producer is basically what I do. If you're interested, you can see my astrophotography gallery and other photography galleries at my main website. It's just starpathimages.com, and you can view the astrophotography galleries by just clicking on the photography samples right here, and then just going to the astrophotography gallery right here. And there's plenty to look at right here. So, all right. So tonight, since the moon is almost full, it would be about pointless to try to hunt down some deep space targets. Looking at galaxies would just be washed out. Nebulas would be washed out. So what do you do when the moon is out bright? Well, you look at the moon. You do a little exploring, little lunar exploring. So that is what we're going to attempt tonight. And so for better or worse, I am learning this whole live stream process, so please bear with me. Doing live streaming and astrophotography at the same time is like spinning a dozen plates all at the same time, and so it's not uncommon to drop a plate here and there, so just bear with me. I will be checking the chat every now and then, and hopefully I can answer any questions that come in. But forgive me if I miss one here and there, because I'll be going back and forth from looking at the telescope and about 10 different screens here. So, but we're going to give it a try. So let's see what we've got. Right, let's see if we can pull up the telescope view here. All right, so we are looking at the very edge of the moon here. The telescope that we're using tonight is a Celestron EdgeHD. It's a 8-inch Schmidt-Cassegrain design, and the focal length is 2032 millimeters. So we're zoomed in pretty tight on this thing. And let's see if I can get it a little bit more centered. So here we can see some of the impact craters, and you can see these white lines that are coming off of these craters. These are called ejecta lines. Let's see if we can find either Copernicus or Tycho. Okay, so we are zoomed in pretty tight here. We might be able to see some collapsed lava tubes in here. If we go over some of the dark areas of the moon called mare, those are basically they're like lava fields that have basically smoothed over and solidified, and a lot of times you'll see like collapsed lava tubes. They just look like these little spidery lines on the surface of the moon. Let's see if we can find something like that. Okay, so here we're looking at one of the dark mare parts of the moon. You can definitely see the ejecta lines in through here. And I'm going to zoom in. I'll tell you, the seeing conditions tonight are just absolutely horrible. You can see the wobble in the image. and that is basically the water vapor in the Earth's atmosphere. So it's almost like looking through a fishbowl at the moon. So you get this kind of rippling effect. And the according to, actually, let me double check the seeing conditions here. So according to Astrospheric, it looks like, let's see, our transparency is actually above average, but yeah, the seeing conditions are definitely below average. The temperature is about 30 degrees. Feels a lot colder than that out there tonight. It took me a while to get set up tonight. I had to change configurations on the telescope. I went from a lens that was 135 millimeters all the way up to 2032 millimeters. So having to refocus the autofocus took quite a while tonight. It takes some doing. But so anyway, I'm just going to kind of hunt around a little bit. We might zoom in a little bit tighter here. I don't know if the since we have so much wobble in the atmosphere, if I zoom in anymore, it might just make it even more blurry. But let's give it a shot here. So 720p is holding up okay. I think that's probably going to be about the max. Okay. So I believe we're looking at, let me zoom back out. I believe this is Tycho, if I'm not mistaken. So the crater that we're looking at here is probably one of the largest and most dramatic craters that you can see on the moon. It's visible pretty much year round, as long as it has sunlight on it. And if you look right in the center, let me zoom in a little bit tighter here. If you look right in the center, you can see it's actually like a mountain ridge that's right smack dab in the center of that crater. And how that forms is whenever the asteroid or whatever it was that impacted the moon, essentially it sprays ejecta out all over the surface of the moon. And just like how a water droplet, when it hits the surface of the water, that rebound of the droplet is actually exactly how these form. So it forms like a little mountain ridge in the middle of most of these craters, especially the large craters. Over time, that can get eroded, and get it centered better here. So they do kind of erode over time. All right, let's zoom back out. And let's look for something on the very edge of the moon. Oops. So one interesting thing about the moon, whenever you're viewing it under like a totally full moon, pretty much like what we have tonight, you actually lose a little bit of the depth and the three-dimensional feel, because the sunlight lights most of the areas in the crater, so you can't see any shadow areas to kind of fill that depth. So, you know, it's always fun to explore the moon during a full moon as well. But I really prefer when it's about maybe 3/4 full, because you start getting these shadows, especially on the edge of the shadow line. You'll get these shadows inside the crater, and you have a much better feel of the depth of them. You can see the mountain ranges a lot better. Let's see here. We'll explore around a little bit more. We'll go up to the north pole of the moon here. Actually, I shouldn't say that. It could be possible my camera is inverted, so this could be, we could be actually looking at an upside down view. So this crater that we're looking at right here, just up and right of dead center. Notice how it's kind of elongated. Now this can be from different reasons, but it can be everything from like kind of a glancing or a low angled impact. But probably what this is was two impact craters together, and whenever the second one hit next to the first one, it kind of liquefied and turned that area again into lava, and basically they just kind of solidified together to form one longer but elongated crater. Sometimes they can also collapse in a little bit and form more elongated craters like this as well. A little bit higher here. Check the chat. So Kieran asks, how can you tell if the camera is inverted without going outside to look at it? Normally that's very easy. If I think that the camera's inverted, sometimes I can look at it in the planetarium view, and actually let me show you that. I'll switch this over to preview. I'll go into the planetarium view of our acquisition software, and generally speaking, this shows me my camera orientation. I am a little bit tilted, but it looks like it is right side up. But if it's a lot more difficult whenever you're zoomed in super tight like this, for sure. And it's also a lot more difficult on the moon unless you really know the craters even zoomed in tightly like this. I was hoping, as I was watching the weather tonight, I was hoping that conditions were going to be a little bit better. A lot of times they'll start to improve as the night goes on, but it looks like it's going to be about like this all night. So we'll have this wobble, but it's actually not too bad to just to kind of do some hunting and exploring around whenever the conditions aren't optimum. It's one of the good things about lunar observations is conditions don't really have to be perfect to really see some pretty cool stuff on here. I probably should use, I'll do this another time, and I'll use another telescope that isn't zoomed in quite as much. Either that, or I'll put a lens reducer on this telescope to where we can see the whole thing, but then I can zoom in with video a little bit, and that way you can kind of get oriented a little better You can see things like the Sea of Tranquility, and you can tell that from other mare. Let's go up a little bit higher here. You get a lot of these really large mountain ranges up around the top north side of the moon. You can see some here. One thing that's really interesting about these mountain ridges, whenever you're watching a solar eclipse, as the moon goes in front of the sun and it's completely over top of the sun, a lot of times you'll get sunlight that will start shining through the moon, and you can actually see the mountain ridges on the moon. And as the moon just starts to move in front of the sun, as that first sunlight starts to peer through the moon, the mountains of the moon, you'll get what's known as Bailey's beads. It just looks like these bright, super bright white beads right on the edge of the moon, and they only last for a very short period, because as the moon starts to move in towards the moon, those will disappear. But once the moon crosses over the sun and it starts to appear on the other side, you'll get Bailey's beads as the moon starts to exit the sun as well. If I'm not mistaken, these are some of the largest mountain ranges on the moon. Now, some of this is probably in deep shadow. Let me raise up the exposure a little bit and see if we can see a little bit farther into it. Not really. That is some pretty intense shadows right there. Let's see, let me zoom in a little bit tighter here. I think, I don't know if the focus is going to be good enough to see it, but you can certainly see the ejecta lines coming off of this crater right here. Double check the chat here. Let's see, another question. Do you have any images that show Bailey's beads? I do, actually. I can show you on my website here. Here is a really bright one. And you can see how the sunlight is kind of streaming in through some of the mountains of the moon. And let's see, I've got a better one here. So this was during the 2024 total solar eclipse. Go back to interaction here, but you can see the bright white spots where there's gaps in the sunlight, and that is caused by the mountains of the moon. The huge red areas, those are actually solar flares. let's see here. I think I've got a different one. So this is also, now this was during the 2023 annular eclipse. Now the moon didn't quite cover the moon, but you'll still get Bailey's beads. You can see some Bailey's beads on the right side of the sun here. This was taken in Albuquerque, New Mexico, and for the total solar eclipse, I was in Indiana. We were in Bloomington, Indiana. Let's see what else we can see here. So I'm going to zoom in on this crater a little bit and see if I can get focused a little bit better. This might be about as good as it's going to get, but let's see what we can do here. Sometimes this is kind of a mug's game here. I'm trying to focus when you've got so much atmospheric wobble. That's about as good as it's going to get. Normally I can zoom in to like 240p or 360p in video, and I can really focus nice and sharp whenever the conditions are better. But tonight it's only going to give us down to about anywhere from 1080p to about 480p. So I do have some other moon images if you're interested in checking out a different gallery. I have a page on AstroBin, and basically if you just type in astrobin.com, let me show you here. Whenever you go to AstroBin, just scroll down and then click on Browse Images and Videos. And when you click on that, if you want to see my gallery, just type in Alan in the search bar, hit enter, and then all of these images are my images. If you click on one, it'll show you that image, and then you can click on my name and it'll actually take you to my profile. And say for instance, here's one of the moon images, and the reason I'm showing you this is if you scroll down underneath it, you can see like what types of equipment that I was using. Using an ASI 174mm imaging camera for this one, the UV IR cut filter, things like that. It'll show you the time and date. But so anyway, get back to the real deal here. Let's see if we can get to the other side of the moon here. So a lot of times people will ask whenever they're talking to somebody that's actually looking at the moon through a telescope, inevitably you'll get the question, can I see where the Apollo moon missions had landed, or can we see the like the American flag on the moon? And currently we do not have a telescope, at least an Earth-based telescope, that's powerful enough to even come close to seeing that. We are in the process of building one, if not two, telescopes that, if I'm not mistaken, they might have an actual chance at that type of magnification, but it is extremely difficult to see something that's that small. You're basically talking about a 1 meter square on the surface of the moon. Just for comparison, like some of these craters that we're seeing here are, they might be 25 miles wide to 50 miles wide, I guess would be a good estimate for these craters here. So distances are really tough to figure out whenever you're looking at objects in space like this. Let's see here. Let me show you a couple of good resources if you're thinking about possibly getting your own telescope, and you're curious about maybe how to find objects in the night sky to look at. Let me show you one resource here. This absolutely fantastic. This is called Telescopius, and it's just telescopius.com. And if you click on any of these tabs, it'll show you, like, say for instance, you click on the galleries tab and click on most popular. It'll show you a list of the galaxies that are basically in the night sky at this particular time of the season. And on the right side here, it'll show you what the position currently is on this graph. The green center line is basically the meridian. It would be either the north or south meridian. And the higher that this little dot goes up, where the target would be, it means that it's going to be higher overhead. And anytime that you can target an object that's pretty much directly overhead, you're going to get the best views, because you're actually looking through less atmosphere, less wobbly atmosphere. But anyway, this is just a fantastic resource, and again, that's just telescopius.com. Back here. I will be right back. I will leave you with this this view of the moon here, and I will be right back. Come on. You got pee-pee? Okay, sometimes you have to let the dog out in the middle of your live stream. All right. So let's see if we can find some of these collapsed lava tubes. Might not be able to focus in on them with this much wobble, but I'm gonna give it a shot. Okay, so if I'm not mistaken, this is actually one here. Let me see if I can get it centered up. We'll zoom in on it a little bit. So this dark line right here, if I'm not mistaken, that that very well could be one of these collapsed lava tubes. Sometimes they'll have like branches off of them, like little tree limbs or something like that. But I don't know. I find these kind of fascinating. Unfortunately, there's so much wobble right now. We really can't get it any sharper than this, but it's going to be about as good as we can get it. Just kind of keep hunting around the edge of the moon here. So you can see here in some of these larger craters how they have that mountain right in the middle of it. It almost looks like a little bullseye. Excuse me. And these really bright, so let me back up a little bit. These really bright craters, like this little one right here. Generally speaking, this means that it's just a fresher crater. It's not quite as old as some of the ones that surround it. From what I understand, they can also turn a little white from certain types of erosion, but erosion is very, very slow on the moon. So normally it means that they're just a fresher crater. The exposure just a little bit, blowing out some of the highlights in there. Okay, so we have another question. Can you see the moon features better when the moon is full or when in some other phase? You can see the features about the same as long as the seeing conditions are good, but whenever the moon is full, you just lose a little bit of the depth. It'll still be just as sharp, but you lose a little bit of that 3D depth feel to it. A lot of times whenever you're looking at the moon like this, you'll see like a black circle or kind of like a black square feature like zip across the moon, like very, very fast, like less than a second. Sometimes they'll traverse the entire face of the moon in about a second and a half, and those are just different types of satellites, or they could even be like the space station, and those are always interesting to see. Generally speaking, about 9 times out of 10 when I'm doing lunar observations, I'll see one. Generally, I'll see them when I don't have quite this much magnification, and you have a little bit more surface of the moon to contrast it against. Notice now this right here is my mount control. I have to just tap it, just one at a time, just to get it to move in small increments like this. And it's kind of strange because even though if I tap left, notice it goes up. If I tap up, it goes right. So it's completely opposite of what the arrows, the direction that it's pointing. But this can change depending on what part of the sky that you're looking at. If you're looking towards the east, the buttons will guide you in one direction. If you're looking in the west, they'll be completely flipped from that. And the reason is once you go from the eastern sky over to the western sky, you cross the meridian, so the telescope lens is actually inverting as it's going across the meridian there. Really hoping I could get this a little bit sharper. I know there's some lava tubes into here. There's a lot of really cool features in this area. And surprisingly, I don't think I've seen any satellites go by as of yet. We'll go back in towards the center of the moon now. This is an area that I often use to focus. There's so much contrast here with these really, really bright craters and then these dark mare areas. See if I can zoom in a little bit tighter. And it could be possible my scope is a little bit out of collimation. I just switched from I had a lens adapter on the front called a Hyperstar, and that takes the exact same telescope from 2032 millimeters all the way down to 390 millimeters, and you have to collimate meaning focus the scope each time that you do that. And I did just kind of like a very quick collimation tonight, but it might not have been quite good enough, but I think that's about as good as we're going to get it. Zoom all the way out here. So whenever you're actually taking images of the moon, it's totally different than if you're doing like deep space imagery of like a nebula or a galaxy, simply because the moon is so bright. A lot of times, even though the camera that I'm using is actually a dedicated Astro cam, it's made for looking at space objects in space. The moon is so bright that I have to turn the exposure a lot of times all the way down, almost to zero, just to be able to get a nice clean image of the moon. I have to turn the gain almost all the way down. Whereas if I'm looking at, say, like a very, very distant galaxy, I might have to turn the gain all the way up, and still it's just all you see is just a little smear across the black sky. So it's just I find it kind of interesting, the range of difference that you have when you go from deep space to lunar. So the reason that these ejecta lines are so long, I mean, you're talking hundreds and hundreds of miles that these white lines stretch out across the face of the moon, and that's just simply because of the velocity of these asteroids or meteorites impacting the moon. It's not uncommon for a meteorite to be traveling over 100,000 miles per hour. So whenever that hits the lunar surface, it just sprays the lunar regolith, just that far. Fortunately, the Earth has, generally speaking, enough atmosphere to burn up most of those meteorites. But the craters that we're seeing here were actually formed by fairly large impacts. Some of these might be millions and millions of years old. But fortunately, they, the smaller ones will burn up in Earth's atmosphere. So another question: what is gain? Gain on an Astro camera is just like ISO on like a DSLR camera. It's basically the scale of how sensitive that the digital sensor is reading the light. Say, for instance, if you raise the gain very high, it's going to make the sensor super sensitive to any light, and vice versa. So it's almost like volume. It's almost like a volume knob, except for instead of for audio, it's for light. see if we can figure out what we're looking at here. I'm going to look at our planetarium software. This is called Stellarium. Let's see here. We're going to zoom in on the moon. Let's see, I think, if I'm not mistaken, I think we're in this region right here. Or maybe right in here. Let's see if I go up a little bit higher. We'll hit Copernicus crater here. No way. Kind of following these ejecta lines to get to the crater. I believe it almost looks more like Tycho, but zoom in a little more. You can really see the kind of the southern mountain range, the crater rim. There's just a little bit of shadowing in here. If I'm not mistaken, this crater is about 75 miles in diameter.
What we do here is go back.
Alright, so we're watching, obviously, video frames right here at 1080p resolution. I'm going to switch over to preview mode, and we're just going to do a single exposure. I'm going to click this button. That's our shutter button. Okay, yeah, so that is Tycho. I get a little bit, or obviously a little bit wider view when I'm doing just still images in comparison to video. Right into about the center of the moon here. Yeah, these areas right here are really cool. A A lot of little contrasty features in through here. And if I'm not mistaken, let me do another still image real quick here. Yeah, okay, so what we're looking at here is we've got Tycho and then we've got Copernicus craters. These are the two largest ones. Back to video. Copernicus. We can zoom in on this. Notice how Copernicus crater actually has like these multiple rings around it. You've got the center kind of mountain range, and then you've got an inner ring, and then you've got an outer ring. And I'm not exactly sure why that is. I guess it's probably just over time, just erosion just forms this inner band. But I find this kind of interesting. Take a picture of this real quick. The software that I'm using here is actually called ASI Air, and the computer that I'm using. Oops, I need to increase the exposure on that a little bit. But this is the ASI Air Plus is the acquisition computer that I'm using, and the software is just the ASI Air. Oops, wow, that's too much. All right, so we will turn down the camera. Oh no, gain is all the way down. Let's try this again. It's going to be finicky here, so I'm going to raise up the gain just very slightly and then drop this back down. This is our exposure time. A little bit more. Raise up the gain just a little bit more. So it's kind of strange, like as you're looking at different parts of the moon and you're imaging different parts of it, your exposure times can swing wildly. The reflectance of the moon is so different according to what part of the moon that you're looking at. I think also my white balance is a little bit off here. One interesting thing about the moon, and you'll see this if you actually do a search for mineral moon and look at the images that you see of a mineral moon, and those are images that are taken with a color camera. Well, they can be taken with a monochrome camera too if they use color filters. But generally they're taken with what's known as a one-shot color camera, and you stack several images together, and then you raise the color saturation like a whole lot, and you'll actually start to see this coloration come in from the mineralization of the moon. And most people don't realize that the moon actually does have color to it. It's not just, monochromatic black, gray, and white. There actually is quite a bit of color to it. Switch back to video. Shucks. I really wish it wasn't so wobbly in the atmosphere tonight, because these are some really cool features right here. Let's see if I can zoom in a little tighter. Yeah, it's not going to show it. This is a really cool mountain feature right here. I'm not mistaken, this might actually be the Sea of Tranquility. Let me take another photo right here. My image actually is flipped. It just means that the camera's rotated a little bit. Check back on the planetarium software. I believe my image is flipped because I'm kind of zoomed in over here, and this is what I'm seeing. So actually, let me show you a little bit more about this planetarium software. This is again, this is called Stellarium, and what I really like about this is you can find all different types of space objects, from galaxies to nebula, comets. It'll even show you, well, of course, all the stars. Let me zoom in on a nebula here. This is called the Rosette Nebula. And you can see how it's got this central core star cluster to it, and all of these really interesting like dark nebula features and stuff like that. It's really cool to just kind of poke around on this type of software. Stellarium is pretty much like the gold standard of what most astrophotographers and astronomers use. There's a lot of different types of planetarium software out there, but this one is it might not be the most full featured, but it's just very user friendly. It's technically, I think it's actually open software, if I'm not mistaken. Open source software. This shows you the zenith, which means that it's directly overhead from wherever your location is. And then if you zoom in to the North Star, which is Polaris, you can see this is the technically Polaris is actually not directly at the celestial North Pole, but it's pretty close. It's the brightest star to the celestial North Pole here. All right, back to the moon. Let's see. So raising and lowering the gain is like opening and closing the aperture. It's not like opening and closing the aperture. It's basically just done through the electronics of the camera. It just raises the sensitivity of the sensor. But you can, of course, increase the light by opening up the aperture of the camera as well. And then another question is, do you have any mineralization images? I do. I can show you a mineral moon. I will show you on my website here. Where's it at? So in this image, and this is what's known as a mineral moon image, but you can see how it's got like these blue areas, and then other areas have kind of like a reddish or brownish look to them. There's even like some cyans where this blue mineralization has mixed in with the white ejecta of the craters. Sometimes, like in really powerful telescope images of the moon, you can even see what almost looks like a magenta color to some of the areas. But this is a pretty standard mineral moon image. You'll get the blues and the browns and the reds. Check Astrospheric again to see if our conditions are getting any better. Nope, they are not. They're pretty much going to be the same for the next several hours. Actually going to get a little bit worse as it gets towards morning. Let me explain kind of what I'm looking at here. This blue line right here is the demarcation line for the time, and like this top this top row right here is like the cloud cover, and this is how they determine the transparency, which is right here, which ironically the transparency tonight is above average, but the seeing condition is below average. The transparency is basically a measure of like how much water vapor is in the air, or how much cloud cover, or even like wildfire smoke, things like that. Whereas the seeing condition, which is like this bottom row here, and the more blue that these rows are, the better that the conditions are. The more white that they are, this means like total cloud coverage when you see these white columns here. So the seeing conditions, what they mean by that is how stable or unstable that the atmosphere is, how much wobble is in the atmosphere. All right, we'll hunt around just a little bit more on the moon here, see if we can find some different features. Oops, I need to switch back to video. Let's raise up the exposure a little bit more. Now here, I can actually show you what the game does. Let me turn down the exposure a little bit, and then I'll switch it to the gain, and I'll raise up the gain, and you'll notice it get brighter and brighter. It's a little bit less dramatic in comparison to the exposure time, but it in a sense it does the same thing. It can either brighten or darken the image, but the difference is with gain, like the higher that you raise the gain, it can introduce more noise or grain into the image. It's almost like if you're remember film images, you'll see that film grain. It does the exact same thing, except it's just basically electronic noise that is that's on the camera sensor. So we'll lower that back down a little bit. So I was mentioning the telescopes that were there's basically collaborations between the United States and Europe and some other countries that they're collaborating to build these really large telescopes over in Chile in the Atacama Desert. One is going to be called the Extremely Large Telescope, and the other is the Vera Rubin Telescope. But the ELT, the Extremely Large Telescope, if I'm not mistaken, will actually have a possibility of seeing like the Apollo lunar landing sites. I kind of doubt they'll be able to see the flag. That would be pretty difficult, namely because since the moon is so bright, the cameras that they use for these large telescopes are so sensitive that it could just be out of the range of being able to lower the brightness enough to even see any detail. These telescopes, they are designed for deep space objects, but technically or theoretically speaking, it would have enough focal length to see like the lunar lander area, maybe like the tracks from the lunar lander. I just love looking at all these different features. It's kind of funny. The more that you look at these images, you'll start to see like little faces or something in the designs of the or not designs, but in the craters. You'll start to just kind of notice different shapes that kind of pop out. Speaking of really powerful telescopes, we can actually, let me show you something really interesting. This is called Space Telescope Live. Now, believe it or not, this is actually what the James Webb telescope is observing right now. Actually, let me switch it to today's date here. What are they looking at? It says, okay, so this is NIRCam images of a galaxy assembly survey. I'm not really sure what that means, other than that they're using the NIRCam on the James Webb telescope. Let's see if we can zoom in here and actually see the galaxy. Since it's an infrared, we're not really gonna see anything there. But anyway, this is just I'm just showing you this as a really interesting resource. If you just type in Space Telescope Live, it'll take you to this site, and if you click on this upper right corner, you can switch it from the James Webb Telescope to the Hubble Telescope. If I'm not mistaken, Hubble is actually, no, it is not down. It actually is imaging right now. That's interesting. Okay, I know that Hubble was down for a little while. Let's see what it's imaging. Probing the gas in and around the local galaxies mapped with integral field spectroscopy. So they're basically just looking at, they're probably looking at hydrogen gas clouds in like a galaxy, around a galaxy cluster, something like that. But sometimes you'll actually, see like deep into a galaxy core, that they might be looking at like a quasar in the center of a galaxy core or something like that. But it's interesting to just kind of poke around on this side as well. Alright, I'm going to do probably just a couple of more images of the moon here. Let's find something interesting to take another still image of. Zoom in on these. Kind of interesting. These are so bright white. Take a quick shot of these. And normally I would post these images on the website, but since the seeing conditions are so bad tonight, it's just really not going to be worth actually doing saving the images. Let's see, lower that down a little bit more. Raise the exposure. Drop this all the way down. See if that gets us closer. This might be too bright, but I've got a yeah, that's gonna be way too bright. You can see that kind of greenish tint to the image. That's because I'm using what's known as a UV IR cut filter, which means ultraviolet and infrared cut. So that is cutting some of the ultraviolet spectrum, and it's cutting a little bit of the infrared spectrum, but it is allowing a little bit of that spectrum to show, and sometimes that can give you a little bit clearer images. They're really good on like if you're looking at planets like Jupiter, but sometimes they can give you more clear images of the moon, simply because the wavelength of, like, the reddest wavelength going into the infrared wavelengths, since it's a longer wavelength, it actually penetrates the Earth's atmosphere at a little bit higher energy. and it can give you essentially the result is a cleaner image from that. Wow, that's such a contrasty area from the super bright craters into the really dark mare here. All right, let's do one more. It really does look like you're looking through a fishbowl here. Other way. It's the moon is so close to us, at least according to what these telescopes are used to looking at, that they're close enough to where your focus is different if you're looking at the edge of the moon in comparison to looking at the center of the moon. There's that much bulge of the moon that it does cause a difference in focus. You can see that this edge down here is a little bit softer than that far right side that we were looking at earlier. Let's take a picture of this area here. It looks so much sharper in the still image because it's just zoomed out so much more. It's a lot more forgiving with the still images. Let's move a little bit farther to the right. Yeah, I can tell my white balance is off just a little bit. There's just a very slight reddish tint to it. But that's okay. Alright, so I guess that'll probably wrap us up. Oh wait, we do have a question here. Can you zoom out on the video? That 1080p here, I'll show you again. The 1080p version or view of the moon. This is 720, and this is 1080. That is as zoomed out as I can get. This telescope is so powerful that that's as zoomed out as we can get right there. But one night I'll switch over to, I've got a smaller refractor that's about 460 millimeters that with this particular camera, it gives you a really nice like full view of the full disk of the moon, and I'll do that one night because whenever I switch into video on that, it's almost like you're looking at like quadrants of the moon. Like you could split the moon into 4 quadrants, and you could image entire quadrants with that particular telescope. right, so I guess that'll wrap us up for a little lunar observation tonight. I really appreciate those of y'all who joined me tonight, and hope you found this interesting. And like I said, normally I would be capturing some images to post on either my website or AstroBin, but like I said, the scene conditions are really just not conducive for it tonight. But if you would like to see more content like this, definitely subscribe to the channel. Hit that bell icon to get notifications whenever I start up a live stream. I'm gonna try to do better about posting a notification ahead of time, but since it's completely weather related, a lot of times I don't know that I'm going to be imaging until a couple of hours before I go live. So it's a difficult thing to kind of predict sometimes. But if you do hit that notification icon, you will get notifications whenever I'm going to start up the live stream, and hopefully we can show you some images of like deep space nebula, galaxies, things like that. It should be really interesting. But I appreciate you joining, and if you do have any questions, feel free to contact me through the channel, or you can also I'm on Facebook. Just look at Star Path Images on Facebook, and you can send me questions through there. But as always, clear skies, everyone, and keep looking for that strange light in strange places.